Thank you very much, Vincent. I got it resolved last minute. So you can already see my presentation. So thank you very much for inviting me. And like the previous speaker, I got hit quite hard with this virus that we all know very well. So I have to apologize for my voice if it's not carrying through the whole talk, but there is not so much to do about that. So I will give you a status on the atmosphere product from the Sentinels that are already in operation and those coming very soon. Then the next speaker will tell us more about the CO2 emission, which is a little bit further down the pipeline. And this presentation is of course compiled by all the mission manager and project managers for the missions I will present. Let's see. So basically, I will talk about the Copernicus missions for atmospheric composition. Currently, we have Sentinel-5p, the precursor mission flying the Stromme instrument. And very soon we get Sentinel-4 and Sentinel-5 also joining the atmospheric orchestra. I am also adding Sentinel-3 to this mix. I'm the mission manager of Sentinel-3. That's one reason for it, but also because Sentinel-3 is indeed providing atmospheric product operational and also an R&D product that could become operational. Although it's not the primary objectives, they can prove pretty valuable. But I will start with Sentinel-5p, given that that is the current atmospheric mission in the Copernicus program. It was launched in 2017 with a nominal lifetime of 7 years. It's still doing very well, so we have no reasons to believe it will not continue until 4 and 5 takes over the mission. It's providing extremely good data. It has a spatial sampling of 5.5 by 3.5 kilometers, which is better than the mission requirements. And it's producing routine data that I will get back to in a little while. So the mission objectives of Sentinel-5p is ozone, air quality, and climate monitoring and forecasting. It is designed, in addition to being a very good mission on its own, Sentinel-5p, like all the Sentinels, are also designed to make sure that we are continuing long-time series from heritage missions. So it's really carrying the torch also from earlier missions, making sure that we indeed can monitor, in this case, the atmospheric products over longer time scales. And Sentinel-5p, as in the name, it's a precursor also for the 4 and 5 mission that I will get back to towards the end of the talk. I will say a few things about the Sentinel-5p products. It's been operational since April 2018 and in routine operations since March 2019. And the portfolio has been increasing constantly. Started out with the radiance, aerosol, cloud, carbon monoxide, nitrogen dioxide, and total column on ozone. Sulfur and OCHO was added a little bit later. Methane is now an operational product together with the ozone column. There is aerosol layer height and ozone profiles was added in November last year. Just to show you an example of the Southern Hemisphere ozone hole area, as I'm sure you are all aware, 2019 was a special year. The ozone hole was much weaker than it had been basically since the beginning of the measurements, or since the 80s at least. But we see that in the winter of 20 and 21, we were indeed back to the very high values, or the very large ozone holes that we have seen also since the beginning of the proper monitoring there. So Sentinel-5p is clearly contributing a lot here. Show some examples of air pollution monitoring. Sentinel-5p provided a lot of value through this pandemic that we are not quite through yet. These are examples of the nitrogen dioxide tropospheric column over China. It's measurements from February of the years 2019, 2020, and 2021. And we can see in the middle plot, which is from the beginning of the global lockdowns, we can clearly see there is a huge impact of people staying in place, locking down the world, basically, which happened. So although we are all happy to get back to a slightly more normal world, we can see in the plot to the right that also means that we are indeed going back to where we were pre-lockdown in terms of air quality and pollution. Sentinel-5p is also doing methane monitoring. And it's also a lot of synergies, in particular with the GHGSat, which is a Canadian satellite. Satellites. They will have 10 satellites in orbit by the end of next year, is the current plan. They are having a very good resolutions. They can look at single individual polluters, if you like. They are talking about tens of meters. They can resolve things down to tens of meters. This shows an example, and also GHGSat is now part of the ESA third-party missions. It's now adopted into the ESA third-party mission program, and hence it can be utilized more better by the community at large. So these are an example. If you look from left to right, it looks at the methane concentration over a landfill outside of Madrid. The first plot is from August 21, and the second two are from October 21, seen with Stromme on Sentinel-5p. To the right, you can see methane measurements from GHGSat. You can really pinpoint and zoom in on the smaller structures. So clearly, by combining the more global measurements from 5p with the zoomed measurements from GHGSat, we have totally new opportunities for how to monitor methane in this case. So for Sentinel-5p, just some of the outlook in the near future. Like all the Sentinels, we are constantly improving our missions. We are improving our ground segments. And for Sentinel-5p, there is an improved level 1 product being released this summer, together with an upgrade of all level 2 products. And there is a major reprocessing ongoing right now, reprocessing all the products over the operational lifetime of the instrument. In addition to the operational products that I showed you on the earlier slide, there is development of right now 9 new Sentinel-5p pre-operational products listed on this slide. And this is done through this product algorithm laboratory, which is really a fantastic way to get people together to develop new products and to crowdsource some of the things. There is a link. You can look at the products and really get the chance to start exploring them. And typically we will have conversations through Klaus Skippal, who is the mission manager for Sentinel-5p, with COM and with CHEMS, to see if there are any of these products that could or should become new core products to Copernicus. And also for Sentinel-5p in October this year, 10th to 14th of October, there will be a celebration. It's the 5-year launch anniversary, and that's going to be in Sicily this year. So let me move on to the next mission, Sentinel-3. It's a mission that are primarily meant for the large-scale land and marine products, flying 2 satellites, A and B, Sentinel-3 A and B, same orbital plane, but separated by 140 degrees. It's not the classic 180 degree. This is primarily because of the altimeter on board and for products over oceans that greatly improved by this a little bit special separation of the spacecraft. It's carrying a suite of optical instruments, the OLSI and the SLSTR, and it's also having the topography mission with SRAL and WR and the pod support. For this presentation, it's data from the OLSI, the Ocean and Land Color Instrument, that are being utilized for atmospheric products, together with SLSTR. So I just want to show you also, there's the picture of the spacecraft with the instruments to the right, to the left. It's a reminder that the Sentinels will be around forever. So although both A and B are behaving very well for Sentinel-3, we are preparing the future, and 3C is basically ready, and it's right now spending its life in a tent on ground, waiting for one of the 2 in orbit to age and being needed for duty. Also 3D is close to completion. I will show you an example of the atmospheric product from Sentinel-3 by an example. Basically, the 2 operational products are the fire radiative power and the atmosphere optical depth. And as you probably know, that the Sentinel-3 mission is split between ESA and EUMETSAT, where EUMETSAT does marine, ESA does land for most product. For the atmosphere, it's split in a different way, where EUMETSAT does the near real time, while ESA does the offline product. That will be more in sync also with the climate parameter and the long time series. The example I'm showing here to see how this product played together is from last year. Unfortunately, it's getting easier and easier to find these examples. It's from the devastating heat wave in Canada and in northern US last June, where you see temperatures for the land surface temperature were reaching 65 or mid 60 degrees centigrades. To the right, you can see examples of the fire radiative power associated with all the fires that were burning simultaneously on both sides of the Canada-US border during that time. To the left, you have an example of the aerosol optical depth, and you can see the pollution really in the air, or the increased aerosols due to the many fires burning during this period. The aerosol products have been operational for a couple of years now. For the fire radiative power, we have recently done an upgrade. Initially, we could only resolve the fires and the FRP during nighttime and when there were cold pixels nearby due to saturation. We have now improved this by a fusion of two channels on board, and we now can also do daytime detections of fire and fire radiative powers. And this was operationalized in February this year. And unfortunately, this product will be busy, I assume, in the summer too, that we are just entering now. Just to show you some activities, this is not an operational product, but I think it's an extremely important and promising product. And again, this is something we can discuss further at a later stage. Through an R&D chain in ESA, Science for Society, they have done ozone retrievals over Antarctica with the Olche instrument. Basically, this is a byproduct of albedo measurements, and it can only be resolved over white surfaces, where Antarctica, of course, is a fantastic example of a white surface still. This really shows how by using the Olche instrument for this, we can resolve ozone measurement with a spatial scale of 300 meters, which is really fantastic compared to what other sensors in orbits are doing. If you look down to the left, you can see these lines. They might be hard to see, but the red dots are from these are ozone in November and December over an area close to Dome C in Antarctica. The red dots are showing the Olche in Sentinel-3, and the blue line is the Stromme Sentinel-5p. And the green dots is from ECMWF reanalysis of ozone in this area. You can see a remarkable coherence between the measurements, and Sentinel-3 indeed can, under these circumstances of having a white surface, really help resolve very good spatial measurements of ozone. Again, you can see examples. It starts in November. We are in the period of the ozone hole, and you can see throughout December, it is getting out of that region in an oscillatory way, which is known, given by the temperature variation that's happening. I will say a few words about the two missions that's coming, Sentinel-4. Sentinel-4 will be an atmospheric mission that will fly further away from Earth. It will be in geostationary orbits, and it's gonna resolve the atmospheric composition over Europe for CAMS with hourly revisit. And there is a list of the things it will do. It will launch, it will fly on MTGS, and the first will be launched in 2024. And there will be two of these operational at the same time. About the products, there will be level 2 products covering atmospheric constituents that drive air quality with trace gases, aerosol optical depth, layer height, UV, and so on. And there will be auxiliary product for handling clouds and surface reflectance. And also the processor development are where it should be. Version 1 is being delivered very soon, and version 2 and 3 will be delivered after ground calibration and in-orbit verification. And the data will be processed and delivered through EUMETSAT and integrated in the MTG level 2 processing facility. Then 2 slides on Sentinel-5, and I'm done. Sentinel-5 is taking over from Sentinel-5p, being in a closer orbit. There will be 3 of them flying, is the plan. They will fly on METOP second generation type A satellites. They will provide global observation, 7.3 kilometer resolution. It's going to be operated by EUMETSAT, and it's also being launched foreseen in the 2024 timeframe. And a few words also about what to expect from Sentinel-5 level 2. It has a similar but not quite the same portfolio as the geostationary, of course. And you have constituent that drives air quality, climate, and ozone, UV trace gases, aerosols, and auxiliary products. And also here, the development is going well. Version 1 of the processor is delivered, and 2 and 3 will also be delivered after ground calibration and in-orbit validation. And it will be delivered, the processor will be integrated at EUMETSAT together with the spacecraft. So with that, I will thank you for your attention, and I'm sure I can answer questions if that's wanted.